Hello guys, in today's video we are talking about inheritance. So there are people who believe on the left that inheritance is not for code reuse, so it's bad. We should not use inheritance at all if we think about reusing our code. And there are people on the right who think inheritance is for code reuse, so it's good, we should use it. Now I want to challenge both of these people because they might be right, but they are also wrong. Both of them are wrong, and we will see why. Well, let's go into this file and explore why both of these people are wrong. But before, I will just quickly show you an image so that you know exactly what we are talking about. We are going to first look at the case for the people on the left who think that inheritance is not a good thing, so you shouldn't use it. Looking at this image, you can see that we have a class called car. And we have different types of cars. We have an electric car, we have a gasoline car, we have a diesel car, and we have a toy car. Now, all of these cars, all of these different types of cars are still cars, which means that they inherit from the car class. And when we want to construct a gasoline car, we'll just say new gasoline car. And the gasoline car extends the functionality of a car. Okay, now let's go back to VS Code and actually implement this. So we are in VS Code right now, and I will just create the car class. So I'll say class car, and let's write the constructor. Let's just say for now we just want to care about the make. We don't want to care about any extra properties. We're just going to care about the make of the car. Like for example, Tesla, Toyotas, Honda. All right, so now we have a car, okay? And let's say we make another class. We said that we had electric cars. So electric car. So now let's write a few methods that a car does. For example, a car goes forward. So I will make a function called go forward. And what will happen is that all these cars will inherit the go forward method. An electric car will inherit the go forward method, gasoline car, etc., etc. And then let's say we have a stop method. Also, let's say we have a start method. Let's say that these are the three functionalities that we want every car to have. Okay, so now what this does is that it assumes that if we put any code here, we can reuse it in every car, in every different type of car that we create. We can reuse it in an electric car, we can reuse it in a gasoline car, we can reuse it everywhere with every type of car that extends the car class. Okay, so this is good because we are writing code one time up here and we are reusing it everywhere down here. Everywhere we can create any type of car and reuse it. Now this is good, but there is a problem. Well, why is there a problem? Well, let's take a look. Let's say that an electric car starts in a different way. And what I mean by that is the start method here is different for an electric car. Let's say maybe we wrote something like console.log starting the engine. So this assumes that every type of car we create starts the same way. But since an electric car starts in a different way, we have a problem because we can no longer use the start here. Because if an electric car doesn't start the same way as a regular car here, let's say that the start method does something like starting the engine, and an electric car doesn't do it the same way as other cars. So what can we do? Well, we will have to override the method down here. And maybe we'll just say that instead of starting the engine, we are starting the battery. So now what this means is that we are starting to find little loopholes. We are starting to find little problems to our inheritance mechanism. And also, let's come here, down here to the toy car. So you immediately notice that a toy car is just a stupid car. It doesn't start. So what that means is, again, we can't use the start method we inherited from the car class. So we have to override it. And here, a toy car doesn't do anything. So we can override it and say start is just a regular function. But this is, again, another problem, because we are not really supposed to write functions for cars that don't need them. Like, let's say a toy car doesn't know how to start. It doesn't start. So it shouldn't have a start method in the first place. And if we inherited the start from the car class and then we created a brand new toy car and we call start on it, we will have a problem, because what will happen is that the toy car will try to start itself like the car up here, starting the engine. And the toy car doesn't have an engine. So we are seeing that we are experiencing little problems to our inheritance mechanism. So now let's say that what we should do instead is remove the start method here. So once we remove the start method, we'll move it to every single car type. So an electric car will have its own start method, and then a gasoline car will have its own start method. Let's see if I pasted it here. No, I didn't. So we'll have start. I will say starting up the engine. So this is what a gasoline car does. And let's say also that a diesel car starts the same way. So we start to see again that our inheritance mechanism is not working, because we are rewriting the same functions in the gasoline car and inside the diesel car. So what can we do? Well, one person might say, all right, let me create an extra class called gasoline and diesel car. So now this extends a car. And what I will do is I will take the start method here, bring it up here, and remove it from all these car types. And then what I will do is, instead of extending the car class for these two, I will just extend the gasoline and diesel cars. So gasoline and diesel cars. Well, this is great, because now we can create a gasoline car and call start, and it works, because a gasoline car needs to just say starting up the engine or something like that. And then a diesel car needs to call the same methods, since it starts the same way as a gasoline car. But this is again a problem, because remember, we should not be trying to solve inheritance problems by introducing more inheritance problems. Okay, so the reason why we actually even had to construct this class is because our inheritance was not working anymore. So we introduced this class to make it work. So creating more problems to solve a problem. All right, so, well, why is this bad? Now, let's say that a gasoline car also has something that it shares with a hybrid car, for example, because they both have engines, but hybrid cars kind of maybe start in a little bit slightly different way compared to gasoline cars. So we might want to reuse some code from the gasoline car. So what we'll have to do again is to create another class that says gasoline and hybrid car, and then we will put everything that they share together in that class, which will lead to a class explosion. And this is actually a terrible thing to do, okay? That is so bad, so bad. So what we need to do is to cancel out all of this. We need to remove this. So now let's take a look at a diagram to understand exactly everything that's going on here, because as you can see, this is a lot of code. It's kind of a little bit more complicated and complex. So we will go back to the diagram here. This is way easier. We had start methods here, go forward, and stop methods here. So what we assumed was that since we put all those methods here, that every car starts the same way, because the code that was here will be reused across every different type of car. Now we saw that electric cars start kind of a little bit different compared to regular cars. So what did we do? We overrid the method start here. So what that meant is that whenever we created an electric car, it will use the method that is in the class first before using methods that were inherited from here. So now for the rest of these different types of cars, they still used the method start that was in the car class. Now we looked at the toy car. The toy car really doesn't start because it doesn't have a way to start. It doesn't have an engine. And we said that we should not force classes to use or inherit methods or behaviors they don't use. So what did we do? We overrid the start class to actually do nothing. And if we didn't do that, we created a toy car and we tried to start it, call a start method on it. Instead of doing nothing, it would have just ran the start that it inherited. And this start method that it inherited called something like starting the engine, and a toy car doesn't have an engine to start, so we will run into problems. And also we looked at the case when gasoline cars and diesel cars share the same functionality. Since we removed the start method from the car class and brought it down to the different types of car classes here, so each one of these had a start method, we saw that it was using the same function. We were rewriting the start in the gasoline car and in the diesel car, and they were the same. So that was a problem. So what did we do? We introduced a new different type of class called gasoline and diesel car, and we moved the start method into that class. Now when we create any type of gasoline or diesel cars, we could reuse it. But that is a problem also, because we are now trying to solve inheritance by introducing more inheritance. And these cars now inherited from the combined class that we created of these. And the reason why that's bad is because if then we were to have a commonality between a gasoline car and maybe an electric car, then we will have to create another class to then put the method that they share in there, or the methods that they share in there, so that then gasoline cars can inherit from that class. And we will also have a problem because you don't get to inherit from two different classes in JavaScript, at least. So that's not even possible. You cannot inherit from gasoline and diesel car and then at the same time inherit from gasoline and electric car classes. So that's not possible. So we see that we will run into problems, okay? And the reason why that was happening is because this is the thing. As long as behavior is coming from the parent class and behavior or methods are the same for all these different types of cars that we created, inheritance works just fine. It is good. But the moment one of these children has different type of doing things, then our inheritance collapse. Because once these two share same commonality, but then this one is kind of different, then we have a problem, because we cannot have the method in here now because this one is changing, okay? And these two have the same thing. And we said we should not introduce more inheritance to resolve inheritance problems. Okay, guys? We should not be doing that. So when everything is coming from the parent, it's good. But once the children, these two, start to share behavior, it becomes really hard to do, because we cannot share behavior from this gasoline car to this diesel car. Inheritance works when it's like this, when it's coming up and going down. When we have to share behavior horizontally, then we start to have problems. When we start sharing inheritance between children of a parent, we have a problem. Okay, so that is why people argue that inheritance is bad. So we shouldn't be using it. Okay, so we've argued for the people on the left who says inheritance is not for code reuse, so it's bad, you shouldn't be using it. We have seen the reasons why they are worried that inheritance might lead to problems when we use it for code reuse. So when should we use inheritance? Well, so let's say we create a brand new array is equal to new array, and then I say array that there are all these methods that I can call on an array. Now, every time we create a brand new class, we have a constructor, and then we write the methods below the constructor. Okay, so what happens is when we enter inside the constructor, we are referring to this object if we want to assign it properties. We are saying this.name, for example, is equal to name, this.age is equal to age. But when we want to write methods, we don't do that. We go down below the constructor, and then we write all the methods that we want to give to that object. For example, get age, which will get us the age. And what will happen is when we do that is all those methods below the constructor will get bundled and put into the prototype of an object. That way, whenever we create a brand new array, we can just call the method, and even though that method doesn't exist necessarily in the object itself, in the array that we created, it will be inside the prototype of the array that we created. So what that means is all the functions that will be inside the prototype are inherited. So JavaScript just wrote them one time and put them inside the prototype of any array object that will be created from calling new array or creating an array just like this. So the argument here for these people is that inheritance is working great. And now let's draw the conclusion between these people. So as you can see, the second people really, their case is simple. We didn't have to go through all these different types of things. It's just one array and we create it, and every new array object that we create will inherit all the properties and methods that were put inside the prototype object. And this is great. It's working fine. Code reuse is being applied, and it's great. So now, when is inheritance good and when is inheritance bad? So let's say that you are creating a class and there's a high chance that you don't end up instantiating that class. You don't end up calling new car. You should not use inheritance for code reuse in that manner. As you can see here, we will not be newing up a new car. We will be newing up subtypes of cars, like electric car, gasoline car. We'll be saying new of these cars. And whenever you have different types of cars, a high chance that you might run into problems when you attempt or when you try to use inheritance for code reuse here. But when you only have one thing, when there's a likely chance that you will have one type of car, let's say you don't have all these, like you just want a car in your system and you will be newing up a brand new car, it's okay to use inheritance for code reuse because you will be creating only one type of car, just a car. And everything that you put in there, every method that you put in there, you can reuse it with every car that you create. So that is the final argument here. inheritance is not good when you have different types of things, because you can run into problems as these things may have the same behavior names or behavior types, but they do it in different ways. But if you just have one single thing, inheritance is good because everything that you create from the class is the same exact same thing. Every array that you create is an array. It doesn't matter. They are the same. So they share the same functionality. So using inheritance in that manner is a great thing. All right, so that's all I have for you today, guys. I'm not used to making videos like this, so excuse me a little bit if it's kind of, a little bit off, but hopefully I get used to making videos like this and make it way easier for you to understand. And we will be back soon, hopefully, to talk about maybe what should you do instead of using inheritance if you want to reuse your code. That's up next.